The word compound simply means there are two or more of them. So they're going to smush together two or more inequalities in one problem. You'll see two types. One of them will say and it's going to include the overlapping region of the graphs. No, I know. We would just not do math ever for the rest of the year. When you have x is greater than 2 and x is less than 6, here's what that looks like. Draw a straight line. Let's make 2 be right here. And count all the way to 6. 2, 3, 4, 5. I'll make it a little more spaced. 3, 4, 5, 6. And you could go up to 7 or down to 0. When you graph x is greater than 2, because Pac-Man does not have a chin, you are going to leave it as an open circle. Because x is greater than 2, Pac-Man does not have a chin. There's no line. It's just greater than. Graph it with an open circle. Then go to the x is less than 6 portion. Pac-Man does not have a chin, so it's an open circle. This less than does not have an equal to. Put the circle open. And then you're going to look at what these are saying. Since x is greater than 2, it's got to go this direction. Since x is less than 6, it has to go this direction. What's going to happen to the two lines? They're going to combine. When you have an inequality that's compound with an and symbol, the and is going to connect the two sections and will always have the line connecting both. So your answers could be anything in here. Could it be 2? Turn and talk, 30 seconds, go.
Not really.
3, 2, 1. Could this be 2, Porter? It's only greater than. So the answer options are anything between 2 and 6, but not 2 or 6. It could be 2.1, it could be 3, it could be 5, but not the actual number that the line is on. That is your and compound inequality. What happens if it says or? What is happening? Lame sauce, that's fine. Sure. The graph of a compound inequality involving the word or is the combined region of the simple inequality graphs. These are not going to overlap. You're going to notice there are two different sections, and you're just going to take both of them combined as the answer. X is less than 2 or x is greater than 6 looks like this. If there is an or, you're going to plot like we did before. And Pac-Man doesn't have a chin, so puts the circle opens. Since it is less than 2, which direction does this thing head, left or right? It's going to be left. It is less than 2, so it's either 1 or 0 or -1. It's going away. What happens to the x is greater than 6? Well, I'll put a circle open on 6, and it's going to be bigger than 6 to the right. What happens to both of these inequalities? They go away in opposite directions. So your answers are anything above 6, 7, 8, 9, 10, 11, 12, 13, or anything below 2. It does not include that region. Those are your two differences for your compounds. One could be or, the other could be and. Quick reminder, if Pac-Man has a chin, which did not occur in those two examples, you're going to fill that circle in. If Pac-Man has a chin, fill the circle in. So anytime you see a equal to, you're going to put a circle filled in. Yeah, get over it. If it is an open circle, it does not have a chin, leave the circle open. Example 1. Sometimes when your inequalities do not say and, they will still mean and, but they'll just be looped together like one big problem. So for this problem, I have x plus 2 is less than 8. When I have a 2 in the middle of the x, I need to get rid of this 2. We have never seen a problem like this, so hang with me. I'm going to move this 2 to isolate the x. Kind of like an equation, I want to get this x by itself in the middle. I want to know what x is greater than or equal to. On both sides, I'm going to subtract 2. It's like an equation. Whenever you do to one, you have to do to the other. So you're going to get 2 crossed out in the middle. X is by itself. You subtracted 2, so I don't flip this sign, only when you multiply or divide. 8 minus 2 is 6. 4 minus 2 is 2. Because the 2 in the middle was not making the x isolated, I moved it. The opposite of plus 2 is minus 2, and I get an inequality that looks like this. Let's graph it. Make your line. Two, 3, 4, 5. X is greater than 2. X is greater than or equal to 2. You're going to read from the x going towards the number. X is greater than or equal to 2. You can also write it like this if it helps you see it better. So I'm going to put 2. Is the circle open or closed? Silent hand. Kieran, why? It has a chin, fill the circle in. So put a circle closed, and it's going to be greater than. How did I know that x was greater than 2? What about the inequality showed me that? Just give me a detail that you notice. How do I know x is greater than 2? Wyatt? Because the mouth is... Yeah, I just want like the detail of that position. If the mouth is opened up toward it, you read it as x is greater than. Go to the 6. Fill the circle in. Pac-Man has a chin. X is less than or equal to. Head less than 6, and these meet together. Tony. Is there any way to find out what exactly x is equal to? It is all of these. So any of these work. You could have x be 3, x be 4, x be 5. It could be 5.5. All of these are your solutions. So unlike an equation, an inequality has a lot of solutions. Sometimes infinite, but usually a range that doesn't work kind of keeps it from that infinite category. You could write this as x is greater than 2 and x is less than or equal to 6. This is the same thing as this written. Because they connect, you could write and as well. Next page. Sure. Let's look at this guy. And I'm going to try to get x by itself. Yeah, Jordan. Go ahead. Just like an equation, I start with a number that is farthest away from the x, and that number is 3. Kick out 3 on both sides. You're left with 2x inside, -8 on the left, and 6 on the right. What would I do next to get x by itself, Kieran? By what number? On which side? Good. I divided by a positive. Do I flip the sign, whole class? No, only dividing by negative. Okay. -8 divided by 2 is -4. And 6 divided by 2 is 3. Your compound inequality looks like this. You could also write it as x is greater than or equal to -4 and x is less than 3. Take a minute to graph it. Check with your partner that you have the similar looking graph. Be careful with Pac-Man and his chin. He's very particular about the way his chin looks. One part has an open circle, the other is closed. Which direction do they go? Help me plot this one. Colby, where does the first dot go?
First dot goes at -4.
And does it go left or right?
It goes to the right.
If you initially put a left arrow, it's tricky sometimes with compounds because you read the inequality like this. If that's kind of confusing you, go ahead and write it the and way so that you can see what the x is doing. X is bigger than. X is bigger than -4. So we're going to be bigger than -4, which is going to the right, and less than 3, which is going to the left. These things should connect. A key also is anytime you have a compound inequality look like this, they will always connect. Anytime it says and, they will always connect. The only time they go away from each other is if they say or. Example 3 is like that, so let's do one more, then you can try it with your partner for example 4. I'm going to take each part of this thing and simplify it to get x by itself. Since -4 is being added to x, I'm going to add 4 on both sides. And you get x is greater than 5. There's one part of my compound graph on the right side. What do I do to both sides to get x by itself? Felix. Good. And x is less than what, Kingston? X is less than what? Okay. So my two possibilities are x is greater than 5 or x is less than 1. Because it says or, which way should my two inequalities go, Porter? Should they connect or go away from each other? They should go away. That's my key. Before I even graph it, I can get a visual of what they should be doing. So go to the x, it's less than 1. Go away from the 1 to the left. And x is greater than 5. It's bigger than 5. It goes to the right. There's your graph and your answer. If you're done with that, I'll leave it on the board. If you're still writing, go ahead and do number 4 on your own. Check with your partner when you get the answer. I wonder if you have any. If you're done with example 4, go to bottom. Example 4 scanned most of our work, and it looks similar to this. If you have a 3 that's filled in going to the left, that's correct. 4 is open going to the right. The one thing I'm going to add when you guys are graphing, I'm going to pass out, actually no, you have graphs for you. But if you're ever making a number line, just put the arrows on the number line because they go forever. Small picky thing that I'm going to ask you to do. You could also add an or here because that'll change some stuff. Great. Your bronze problem is going to start with graphing. It says to solve on a separate sheet of paper. If you want to use the space to the right and underneath it, I need to see you actually solving this like we did in notes. You can't just look at it and mentally in your head try to do it and then graph. I want to see step by step how you got x by itself. Take out your partner clock. If you don't have a partner, you're going to raise your hand. If you do have a partner, you're going to point to that person. You did 10 o'clock yesterday. You did 7 o'clock the day before. Point to your 8 o'clock partner. If you don't have a partner, you're going to find a group of 2 that was not yesterday's group. 30 seconds, go. So Maddie, you were with.
Oh, I never got to sign it. Oh yeah, I did. Yeah, I did.
You see the video? Hey, you took my paper. Here, my paper. You know the mic.
Look out.
No, there's no tax. They got that right now.
What is
3 years. I'm gonna force everyone.
We are almost at 100%. That was 30 seconds. I need one group. Pencils on paper. We are there. Thanks for being on task. And you got 8 minutes. And then we'll go back. Not good, I'm bad. Sorry. Who is absent today? Anna, you're here. Anyone else here? Waylon Thompson.